So let's do another comparison test example, but one that's a little bit more complicated. So we want to prove that the integral from 1 to infinity of x over square root of 4x to the fourth minus 1 diverges. This is another example of an integral. It's going to be fairly difficult to calculate, but what we don't need to. All we need to do is show that it diverges, that it comes out to infinity. So we're not even going to have to find an antiderivative. Now, the key to understanding this problem, the reason I set it up this way, is that some of you may have been looking at the last example and say, yeah, I get it that that if you can compare, if you can write an inequality comparing the given integral to something like 1 over x to the 3 halves, you understand what a p integral is, you understand the very simple rule that says whether it diverges or converges, but how do I know what to set up the comparison with? So some of you may remember that there was this rule there's this kind of shortcut from Calc 1 that said that if I have a limit as x approaches infinity of 3x to the 10th plus 3x squared minus 7x over 5x to the 10th plus 9x to the 8th plus 1. Let's say the point is you look at the highest powers essentially, and of course, then you also had, when you looked at the highest powers, you had to consider things like whether you were taking a square root of the highest power. Essentially, it's this sort of rule that we're using to determine what to compare it with. So the idea is that if you look at what's going on in this integral, in the integrand rather, the essence of it is kind of given by this. Okay, so we sort of have this intuition that the number we're looking for, that the function we're looking for is going to be x over the square root of 4x to the fourth. That's going to come out to x over 2x squared, which is just going to be 1 over 2x. Now we know that if I gave you 1 over 2x and asked, does that integral, it's an infinity sign, does this integral converge or diverge? You would say, oh, I know what that is. That's just going to be 1/2 integral from 1 to infinity of dx over x, and say, yeah, that's we know by the p integral rule that clearly diverges. So that's not a proof. You can't just say, oh, now I get it, it diverges. That's the intuition. That's the intuition you use to figure out what you're going to compare the integral with. It doesn't mean that you don't have to run it through the comparison test and prove either convergence or divergence. So okay, so anyway, with all that said, here's how I'm gonna set this up. I'm going to observe once again that the square root of 4x to the fourth minus 1 is certainly going to be less than the square root of 4x to the fourth. And therefore, 1 over the square root of 4x to the fourth minus 1 is greater than 1 over the square root of 4x to the fourth. And of course, we only care about this all for x greater than or equal to 1. Now, if this inequality is true, look what I can do. If I multiply everything on these sides of the inequality, on both sides of the inequality by x, it's not going to change the inequality, especially since x is a positive number. We know that it's only between 1 and infinity. So the next line I can write here is that x over the square root of 4x to the fourth minus 1 is greater than x over the square root of 4x to the fourth. Now what is this equal to? This is going to equal x over square root of 4x to the fourth is 2x squared, and that's going to equal 1 over 2x. So now I have the f and the g that I need. So here the inequality actually goes this way. This is all greater than or equal to 0. So that makes this f and this g in the comparison test theorem. So what we can say is that if the integral of 1 over 2x diverges, then this integral, x over square root of 4x to the fourth minus 1, since the expression has to be greater than that, it must also diverge. So we form the inequality correctly. The inequality is going to be, just to write it in the direction the comparison test writes it in, it's 0 is less than 1 over 2x. It's less than or equal to x over square root of 4x to the fourth minus 1. So we can now conclude, bring it over to this side of the page, we can say that the integral from 1 to infinity of dx over 2x, which is equal to 1/2 times the integral of dx from 1 to infinity of dx over x, in other words, I just brought out the factor of 1 over 2, this diverges. Why? Because it's a multiple of a p integral where p is equal to 1, which importantly is less than or equal to 1, because the rule is that if p is less than or equal to 1, then the integral diverges. So we can then say, since the integral that we care about is bigger, its integrand is larger than this 1 over 2x, and we know that if we integrate 1 over 2x it diverges, we can say therefore the integral of x dx over square root of 4x to the fourth minus 1 also diverges. And there we go. We've proven that the given integral diverges, so we end the proof in the classic way. There we go.